Hello, Violin Nabonsavind, welcome. Lecture aban na chal ke rutin na. To hi last video chana chu class 11 portion of part 1 gravitation chani bol cha ta cha. 11 sunga part 1 se ke china unit and dimension ti ho te lo cha. To hi bon ai bol dio units and dimension ho na chai na pen line bol dio cha cha ho he. To hi 11 part 1 is over hi tan to hi 11 part 1 zo hi na. 12 ana bolo hitin so 12 asisi cover ten abal 11 second part akhlur kitin na aji jo 12 for hi to hi board exam piting jong ominten chuke leka vel hin 11 simo sanga 12 simo zo hi series join na chule request jong hun ke bolen request jong hun lunin class 12 person ho he na bolot na aji ajo so class 12 hi ma sapena hi electrostatics so ma hin na electrostatics hi NCERT chapter 1 to chapter 2 aki khat vel khona si hu electrostatics na hoop cho capacitor ti lo si khona so we will do this part first and then we'll go into capacitor and then current electricity data job mane chal dio okay then electrostatic video hi charge to coulombs to alang pia coulombs to boy bol deu cha chala hi aban le electric field potential electric potential energy ti ho na aban mana I chal deu Gauss law ti ho vel na chio zo lang pa electrostatic song di za so first we will see study about electric charge okay charge kiti pa na tang basic ang kalu lo dio ji hi cho hi class 10 azong sim chai ta na charge ke tio current ke tio hi na high school azong temper idea na niu tai na cha cho basic bolo de eva exam point of view ading apoi mo ho chana hi cho che bol de cha so first thing charge ang ke ti phala chun here is two types of charge of na positive charge and negative charge Benjamin Franklin in he positive to negative and p te so na he positive to negative ke ti a value pa ho ke se ni lo cho chi a nature pa ho na so they behave the nature of the charges are opposite that is why we say one is positive the other is negative abala p here ha so like charges repellity usura na plus charge to plus charge ngom mala jun amani ka chu repulsion ngom de na abana chu minus charge to minus charge ngom repel eva attraction chu if the two charges are opposite then we will have attraction unlike charges attract kiti pa na chu hin din abale tang hangpe elementary particles la ake haman pen thum ho chuna heji e syllabus ake haman pen thum ho chu pm tele electrons protons to neutrons atom is you kholana atom sunga ko pima avela hi electrons ki vela asunga ko protons to neutrons ho khom chulana atom za ko so heji electrons protons to neutron ki ti hoina so these are the three most common elementary particles that we have okay ji jo heji mass to charge value ho jong hi hen ngai na masapena mass of electrons is at ham 9.1 into 10 power minus 31 hi jo exam ma value jong ki pi mai thai ki pi lo mai thai na hi jong la value hi by hal lo chuno so remember mass of protons to ham 1.67 into 10 power minus 27 mass of neutrons jong cho mass of proton to akibanga e zoom de cho eva hechala hi so slide 1.667 1.67 tia themar ke slight difference na jong le alang pe so they are approximately equal okay mass of proton to mass of neutron na aban le charge to ha isei ma bangma so electrons are negatively charged protons are positively charged na there are two types of charges okay plus and minus a charge value ki bang so magnitude of charge ki bang na 1.6 into 10 power minus 19 hisa electrons to minus it is also minus e put va hela hi plus e put so proton a na abala neutrons to ham neutron to neutral charge lo na okay so neutral the neutron has mass but no charge okay then next is the basic unit of charge ang kati phala chu pi ke saina ham the charge of the magnitude of charge of one electron or one proton na he chepa ko 1.6 into 10 power minus 19 pa ko na chepa ko basic unit of charge ke di cho the SI unit of charge is coulomb chepen unit of charge 1 coulomb 2 coulomb tana charge in simple en ja deu cha it is denoted by capital C so 1 coulomb to pm tele it is the charge flowing through a wire in 1 second if the current is 1 ampere he current to charge relation pa hi current to pm so charge divided by time na so charge to current into time to so 1 coulomb cho piam veilang hi 1 coulomb hi le chun zilang jong 1 a hi ding a khu current jong 1 a hi ngai time jong khu 1 a hi ngai na so 1 into 1 is 1 so 1 coulomb cho pi na ham 1 ampere in 1 second okay 1 ampere current flowing in 1 second na je cho 1 coulomb te nai cho okay basic nya sa cha hi cho chung hi za na abale next point I had you chu piam tele betang thil kha cho body kha cho na charge au mi ang kati phala khon chu pi ke sai na ham so what do you mean by when we say a body is charged na body kha cho charge is au mi ang kati phala chu he charge pa cho na pi ke sai na ham tele so when we say a body is charged so we always refer to the excess charge and deficit charge excess to deficit charge hong pa chona excess charge hama ilo le deficit china charge pa chona is ana charge to deficit gem he chi pen charge of the body ta dong ke sai cho the example ga ping he su ke do example chemistry sodium atom he chi he neutral cho na he ta ke ji phalan chi neutral atom so grounds then ala he chala he if I remove one electron utile Na plus electron ta ji usula na chala he electron negative khat kala dol chon chala positive khat chu excess am ta chala okay he chala he btang atila chu charge to 0 so need is neutral na neutral ong ki phal chun pitena a neutral body does not mean that the body has no charge the body has no electrons no protons ti nai lo cho electrons btang positive charge negative charge electron proton ho chu maintain a hewanga aum za chu ki bang na plus charge zat to minus charge zat chu ki bang cho so the number of electrons and protons present is same ji chu overall a chu na so the overall charge is it is 0 chu neutral body din nature it means that it has no excess charge okay to chu chala hi excess charge se ma cham lo na ai ba hi chala na ko na hi negative charge khan na do la chun positive charge kha chu excess am ni na da chu okay so that excess charge is the charge of the body to sodium I charge zaramam so +1 na oxidation state hosing voltage na chemistry so here the charge of sodium ion is +1 chito banga chu chlorine khun her chula na chlorine khu electron khat hab belew chun ipiki su di ha so Cl minus hechala minus pa epm 1 electron is in excess na hechala excess pa chu a charge of the body kiti so hechala chlorine pa charge is -1 jula na heche -1 hi pi sainam tele 1 electron is excess okay basic news as a meaning na te phadi he thim ding wa chung ka ko he za chala he so a body can be thus positively charged by losing electrons he chi ti phala plus hongum de ham eti phala plus to excess am ding ham negative charge a ke remove phala na okay similarly a body can be negatively charged by gaining electrons na p bl zone electrons excess a hongum ding he chi excess pa na so that will be the charge of the body okay negatively charged to pitena ham electrons excess aum na positively charged to pitena ham electron deficit aum te jo okay I don't have proton excess aum na okay moving on properties of charge he NCERT am ja chu video properties thomo maintain athomai video masapen chu piham additivity of charge chu additivity of charge chu pitena ham tele example chu he chala he system khat kan cho na system khan cho system sunga he charge let's say charge q1 is 2 coulomb charge q2 chu say 3 coulomb charge q3 chu let's say -2 coulomb na charge q4 chu let's say -1 coulomb de charge lium cho na jela he ala question cho piham kutile he system sunga total charge so is dem na total charge holding also pin the body ham asunga charge zo si jo bona na go khom so ke deu na so q1 plus q2 plus q3 plus q4 chu pi ha 2 plus 3 minus 2 minus 1 chu 2 coulomb chu pi ha total charge okay property ma sapen chu pi ge se na ham additivity of charge he chu pi se na ham tele if a system contains n number of charges okay total charge should be the sum of all these individual charges okay the total charge of the system is given by the sum of all these charges total charge holding a chu system sunga charge jo plus na bol kham de na chu hizing so very simple okay ani na pen chu pi conservation of charge should be ha example bol thot na he thim ding wa chu he chalai system khatum ki cho na so let's say here word ki mang chu pi isolated system isolated system chu pitin ham tel avial la hi charge dang ima cham lo na system sung bo se chu charge am tin system vel la chu charge dang ima cham lo tin chu so no charge in the vicinity na aning la chu kutile hila hi let's say charge 1 to 2 coulomb tin charge 2 to 3 coulomb tin charge 3 to -2 coulomb te okay system khara charge thum cho na +2 +3 to -2 cho ale chun hi system pa hi so it undergoes some process okay any type of process some thermal process na ale hin hi chizo wa hi lai charge mo cho na hi tai hum ta cho charge q1 pa hi so now this q1 becomes 3 coulomb q2 pa hi -1 coulomb kutele q3 pa cho is to them so that is the question atila cho hichi process achi masanga so na before it undergoes that process this was the situation q1 pass to 2 is q2 pass to 3 is q3 pass to -2 so after undergoing that process now q1 becomes 3 q2 becomes -1 q3 pass is them tang chelai conserve ong ketin so pi ha tang conservation i ha bol jing chula 11 la 11% adong chuna conservation of momentum ma conservation of energy o ma na to hi conservation of current ho jing bol de chom conservation ong keti phala chun pi ke se na ha conservation chu initial value is equals to final value okay a value atila value mza to chung a chaina ola zawa value mza chu ke bang ne na khutile chun total charge initial chu jar ha so capital q I te so 2 plus 3 minus 2 to 3 coulomb. So before undergoing the process, atila total charge 3 coulomb. So after the process also the total charge has to be the same, constant, conserve. Hijong 3 coulomb hingai so kutile piha so 3 minus 1 plus q3. Hijo se sin ko khom wala 3 coulomb hong hingai so kutile ga solve le q3 chu janang podo ding ham so 1 coulomb. Okay, q3 to 1 coulomb hingai na. Okay, just an illustration. Netim dasana conservation of charge ki chu initial total charge to final total charge to ki bangle din so. Okay, so there should be no change na. Ale athar na pen so biham dele quantization of charge. Hichi pi ke sai na. So charge body chunga charge on pa so na. Is a charge value pa so it will always be an integral multiple. 1 coulomb, 2 coulomb, 3 coulomb ta chi de na. Example je beta ibolai ta jo ham tele ita hi cho body kha cho neutral body kha cho na jala hi suppose I have a neutral body. It's a neutral body akona hi electron kala do ding ala chun so I can take out 1 electron. Okay, I can take out 3 electrons. I can take out 100 electrons. Okay, hita chu kala do thai chula but what I cannot do is I cannot take out 1.5 electrons. So this is not possible. Okay, I cannot take out root zong na. So root value kila thailo, fraction zong kila thailo, decimal point zong kila thailo. I cannot take out 0.2 electrons. So these are not possible. Aji chu electron zong chu entity di ha khat ni thum ta ke sim tho thai cho na electron khat electron ni electron thum ta ke sim tho thai cho ai ba electron ki khat ta ki bol thailo cho ke bol thailo na ji aju electron khat ila do wala chun charge of body pass of +1 ki so na electron thum na do wala chun charge of body chu +3 hong de cho aji chu +3 excess ta chala na body a cho. So that is why we said since we are able to take out only integral multiples of electrons or we are able to give integral multiples of electron so the total charge will always be an integral multiple of E to ph charge of electron na. Okay, so that is what we call quantization of charge. Okay, competitive exam ta question kedong be se la hojong le board exam kedong khat question khalini ga bolote ajala he. First question chu therefore understanding ga boost na dinga chuna a body acquires charge of this much. Charge of body. Okay, so this is the charge of the body. Body acquires charge of this much charge. Now, the mass of the body will pitina hachi. It's evaluation charge by evaluation plus value. Okay, this is plus 8 into 10 power minus 12 plus 20 pala ham tele electron so kila do phale na electron nala do phale electrons on mass anai chula. Okay, if you remove that much electron, so the mass of the whole body should decrease, right? Okay, kutele hechi mass of electron I holo dio chu. Hechi a charge ke pizana. So charge hechi hi electron is at I holo basat pendiu na. Hechi electron is at chu head vala chun chelai kona chu electron is at a mass pa na. So we can find out the mass. So then we can say whether it decreases by this much or it increases by this much. Kasi banga chu chelai charge pa chu plus hi ja na. It is a positive charge. It means that electron has been taken out. Okay, electron la do vala chun mass should decrease te te ngai na chelai he. Okay, let's see how much it has decreased. How much is that a decrease mass is that a decrease the head and number of electrons here masanga. Electron is like to na. It's electron is like to it head you ham to charge ke pia pan I cat jo. Kutele a one head to biham 1 electron charge to biham 1.6 into 10 power minus 19 Coulomb. Okay. Kutele it's like p biham. So it is called the unitary method na 1.6 into 10 power minus 19 Coulomb chu is that electron aham 1 electron. Okay, kutile 1 Coulomb chu is that electron aham 1 divided by 1.6 into 10 power minus 19 Coulomb. It's the number of electrons ta ji electrons. Okay, divide both side by 1.6 into 10 power minus 19 ka bol so second step ahim 2 hin multiply both side by 8 into 10 power minus 12 Coulomb. 1 6 10 power minus 19 into 8 into 10 power minus 12. It's a number of electrons. To chalahi pp ham dela chalahi electron hichi pen hi value hi pha hichi pen hi electron is at kila to ti jo na ji so this is the number of electrons removed. Okay, hichi ga solve lesson sa ram podo diham. So here you'll have 16 into 5 to 80 na. So 5 into 10 power 7 electrons. Okay, electrons is at remove ta so kutile electron is at mass I hold ngai chura na 1 electron mass is at ham 9.1 into 10 power minus 31 kg so je kutile 5 into 10 power 7 electron to total mass is at ham. So 9.1 into 10 power minus 31 into electrons at 5 into 10 power 7 electrons. Okay, how much mass is this? 5 1 is 5, 5 9 are 45 into 10 power minus 7 8 9 10 11, so minus 24. Or I can write this as 4.55 into 10 power minus 23 kg. Okay, kutile heji piha mass of electron removed chalana. His mass is at remove alison, so the overall mass will be decreased by this much. Okay, answer should be D. Okay, bana a charge of 1 microcoulomb minus 1 microcoulomb represents is like minus 1 microcoulomb kiti so minus chupitinam excess of electron tinai so chala hina kutel electrons ki have betina so body aso electrons na have beval sun overall mass of body so akal ngai so na it should increase. Okay, so that means it will be gained. Option B to C have pen hidina A to D to D lo ta so. Okay, now let's see. Number of electrons hold audio using what's like kutele ehon here to biham. So 1 Coulomb 1.6 into 10 power minus 19 Coulomb na hechi electron is an aham electron khara na je. Okay, kutele divide both side by this one. So 1 Coulomb who electron is an aham 1.6 into 10 power minus 19 electrons. Okay, so 1 Coulomb who electron is an question yung direct ketong thai na. So how many electrons are there in 1 Coulomb? The 1 Coulomb si pike say na so this many electrons. Okay, kutele minus 1 microcoulomb micro so piha 10 power minus 16 na. So 1 microcoulomb means or 10 power minus 6 Coulomb so is at ham. So 10 power minus 6 divided by 1.6 into 10 power minus 19 electrons. Okay, so you solve this one, you'll get the answer. Is that here? Is that the so 10 power 19 ko chito wala sun, so I will have here 10 power 13 by 1.6. So 1.6 to piham 10 by 16 tinai so chala he 0 khat ha bele han 10 power 12. Okay, so 100 by 16 ko so you'll get approximately 6.25 into 10 power 12 electrons. Okay. Electron is a bit in a body as well. So in search of PM, gain of 6.25 into 10 power minus 10 power 12 electrons by the body. Okay. It's a basic charge to properties of charge ta na. To hi Coulomb's law impact du ta cho Coulomb's law. So force na electrostatic force kiti pa ko. Okay. So Coulomb's law. Masa pena chu ikhat point charge ang kiti pa la ko ni pide na ha point charge. Point charge ang kiti lewa chun size of the charge na. Charge a size pa so anyaw na. So the size of the charge is so small that it looks like a point. It doesn't say na if the size of the body is much smaller than the distance separating the two charges. So the charge ni tayo so na siya. Charge by spherical charge assume liao hen radius pa na. So the radius of the charge is, let's say, small r. Distance pa so x tilaw hen. So here if r is much less than x, then we can consider these two charge as a point charge. Okay. Point charge ke tin so piham tela size na. We are assuming that the size of the charge is so small as compared to the separation between different charges. Okay. Avela charge ato chun ka separation so compare wala chun na. So the size are very small, so we consider them as a point charge. Okay, simple meaning chun na. The size may be ignored, so we can consider them as a point. Okay, masapena Coulomb's law so piham. Coulomb's law measures the force between any two charges. Okay. Charge ni ka chu attraction, force of attraction force of repulsion na heche magnitude of force paso heche paso ipin pm tele Coulomb's law na pi cho. So according to Coulomb's law, the force between any two charges is directly proportional to the product of the two charges, the magnitude of product of the two charges, and inversely proportional to the square of the distance between them. Example chila charge q1 na hila charge q2 cho kutila ki ka ahna separation pa chu r ti leo hen amani ka force of attraction pa na attraction repulsion can be anything. Okay, so that is given by this formula. So F is equals to K into mode of magnitude of the mode na modulus Q1 into Q2 divided by R squared. Okay. Here's a K pi pm tela K pa chu 1 by 4 pi epsilon naught. Okay. Here's a value hoput leojon value jo 9 into 10 power 9 hung pot is K value pa hai na. Okay, so remember that value. Okay, question can solve it na. Di bolyo ha. Suppose I have a charge 5 microcoulomb tiute. Charge dang khat ya hilahi 10 microcoulomb na minus 10 microcoulomb tiute. Amani ka separation pa hi, let's say this is 10 centimeter. Okay. Kutile ama sapena chu amani ka hi attraction deham repulsion deham. It's negative is actually positive chulana. So that means they will have attraction. Okay. Unlike charges attract it chulana chulahi. So here the force, the amount of force of attraction between them is given by Coulomb's law. So like Q1, 5 by Q1 minus 10 by Q2 na. Kutile Coulomb's law so apply lao chun K chu piha 9 into 10 power 9 into mod 5 into 10 power minus 6 micro to 10 power minus 16 so into minus 10 into 10 power minus 6 mod divided by so 10 centimeter in terms of meter to 10 power minus 2 the whole square. Okay. Negative charge nei jong leo chun na he modulus omja chu it will always come out to be positive. Okay, so therefore no need to write these negative values. Okay, pana he ja chu ga we me jana helai negative charge omjong le he modulus omja chu plus ke su tho to chu. Okay, so here how much will you have? So 9 into 10 power 9 into, so 5 into 10 is 50 into 10 power minus 12. Minus 6 to minus 6 or minus 12. Now divided by, so 100 into 10 power minus 4. Okay, so you solve this one. 50 into 2, so 100. 4, so minus 8. So I will have here, so 9 by 2 into 10 power 1 na 10 power 9 to 10 power minus 8 to 10 power 1 so here 4 0.5 into 10 so 45 Newton. Okay, answer so. Okay, question solved in Coulomb's law to related question. Then solve you about the vectors form of Coulomb's law about you na about the system of particles and their force hold on about you about equilibrium problem you hold you na. Okay, first question two. 2-point charges A and B having charges plus Q and minus Q respectively are placed certain distance apart. Force acting them is F. Đây charge niệm cho. Charge A to charge B na. Khat pa hi plus Q hi za, khat pa hi minus Q cho. So at some separation. R2 to jala hi. Kutile amang ka force pa hi za ha force pa hi. So K into so Q into Q to Q square divided by R square. Na. Minus Q omjong le kasi bang so mod om ja cho na. So plus Q ki su thau thau de cho. A magnitude pa bo se je de cho negative pa hi lo na. So next question part to be ha. So if 25% of the charge A is transferred to B. Okay. To have the 25% of charge A. So charge A to ha Q to na ji. 25% of Q ong ki division P tinam. Percent ong ki division divide by 100 bola cho na. So 25 divided by 100 into Q. Ki sai na so ji. So beham Q by 4 tin cho. So 25 into 4 is 100. So that means you have to transfer, from here you have to transfer Q by 4 to B. Okay. Ale remaining to PM data chala here. So atila to Q umza. So Q by 4 na remove valachon remaining to 3Q by 4. Okay. Atile khatpena so atila so minus Q umza. Q by 4 na add valachon is at the ha. So minus 3Q by 4. New charge na. That's a new situation to be ha. After all the charges are transferred, A to charge is tam, A to 3Q by 4 ta, B to charge is tam, minus 3Q by 4 ta so to hai. Separation to ki hello na, R mama Kutile question to new force to bihamati cho. New force is tam, F dash tivte. So K into, so 3Q by 4 into, so 3Q by 4 divided by R squared. Negative 3Q by 4 hi so negative pa so la lao deo modulus omzia. So here you'll have 9 by 4 are 16 into KQ square divided by R square. Chila KQ square by R square here piham. Chipen hi F chala na. Question agi picho. So therefore what is your answer? Answer to 9F by 16. New force of attraction between A and B na. So option C. Okay, abana, a charge Q is divided into two separate charges. Charge Q into two pieces. So what should be the value of this each of the charges such that the force between them is maximum? It's depending on the result that you so I have a charge Q. Okay. So I will break into two different charges. Okay. So let's say if the one of the charge is small q, then the other one will be what? Q minus Q na. As total to capital Q is capital Q la to small q na la do remaining to capital Q minus small q. Okay. So what will be the value of the charges such that the force is maximum? Force ga hold out Q to capital Q minus Q na. So amagi separation x R2 so some random separation. Okay. So the force will be what? So K into so Q into Q minus Q into so Q divided by R square. It is a force of force between Q and Q minus Q penso na. Let's say force maximum hong ti so chila evda. Meta maxima to minima kiti khanu meta. Maxima to minima holding a hoiti ki bolzeta. So you have to differentiate it and then you equate it to 0. Okay, abolanso. So here chila hevele chun chipa constant to ki hello. Capital Q zon ki hello, only change is small q. Na he chipa is that hello. So it could be 1 column, 2 column, 3 column, na variable chula ki helele thai chula. So therefore here, so df by dq should be equals to 0. Maximum minimum holding aso na. So the differentiation should be equals to 0. So here force pahita kasi thai. So K into Q divided by R square minus K into Q square divided by R square. Bracket ko hong leo chun na. So here df by dq chu pi de ha. Differential leo chun. So kq into q by r square pa ko kq by r square ke su ding minus abana pa ko q square chu in the differentiation of x square chu 2 into x chu na. So power pa hong kum su ding k into q divided by r square should be equals to 0. Chi solve leo chun sa podium. So kq by r square should be equals to, so 2kq divided by r square. So r square, k. Kutile small q is anong podam, small q is equals to capital Q by 2. Okay, kutile khatpa so q by 2 ahil jun khatpen chu zan ha q minus q by 2 chu, so again q by 2. Okay. Like on the result charge has pieces ki breakdown so for them to have for the two pieces to be to have a force between them to be maximum na aman ki force of attraction force of repulsion so maximum charge na so they should be equal. Okay. So the original charge should be equally divided into two pieces such that the two pieces will have the maximum force of attraction or repulsion between them. Idea cho result and even na. Okay, next hi to I ball pan so is na application part cho 10 Coulomb chu piha capital Q cho it is divided into two parts such that so they are placed between 1 centimeter so such that the repulsive force between them is maximum. 10 Coulomb pa chu total charge cho na this is broken down into two pieces. Okay. Such that the force between the two pieces is maximum kiti chulana the maximum charge so pi so half of the total charge, so that means 5 microcoulomb and 5 microcoulomb. Okay, so that is your answer. Abana force between two charges q1 and q2 placed in vacuum. Okay, so now you have to know something. Coulomb's law in a medium. Formula khan by had me do so chalai he vacuum ahong palachun. So in a vacuum or air, okay, so charge ten ki ka achu vacuum hamela air ham malachun force or chupita, so k into so k chu pita k chu 1 by 4 pi epsilon naught into q1 into q2 divided by r square chalana q1 q2 by r square. Hi charge ten ki ka separation achu region songa chu air ham helo vacuum ham ahong mala so if there is a medium, some medium is there in between. Okay, so having dielectric constant okay, dielectric constant it is the property of the medium na q1 to q2 ki medium pasuna sila medium example so water ham like glass ham the medium dam ahung malachun properties of medium paso dielectric constant ki cho a new formula cho piung ha so formula Coulomb's force in a medium, so here you'll have 1 by 4 pi epsilon r. Okay, so q1 into q2 so divided by r square chalai epsilon r hi pitina ha. So property of the medium na epsilon not ang kiti palachun vacuum hitinai jana epsilon r kiti palachun chichu inside another medium other than vacuum or air na it's epsilon r pa hi, so this can be written as k times of epsilon naught. Okay, so with respect to vacuum, by how much the medium has changed na by how much epsilon has changed so therefore the new formula will be what Coulomb's law in a medium so so Coulomb's law in a medium will be equals to so 1 by 4 pi k into epsilon naught into so q1 q2 divided by r square. Okay, the formula hasing Coulomb's law in a medium. Okay, so like question I happy kidongam vacuum also force to f a so for inside vacuum so like question I na so inside vacuum so the force was what 1 by 4 pi epsilon into q1 into q2 divided by r square na. It's option 1 equation 1 tifte Kutile abana chopiha. If it is placed in a medium having dielectric constant 5 ati cho. Ale to medium sunga chu new force chopidita. So Fm chu so 1 by 4 pi into 5 into epsilon naught. Okay. So Q1, Q2 adang pigi khelam. Distance between them also becomes r by 5 na. Chu r by 5 the whole square. To solve the solution of so 5 squared is 25, 25 is chung lang ding. So 25, anui lang for 5 hat na. So Q1, Q2 divided by 4 pi epsilon naught into r squared. So what is this whole thing? So this whole thing is given as F. Okay. So what will be the answer? So 25 by 5 so 5 is 5 into F. Okay. So answer is option C. Okay, abanahi. Let's solve questions that are related to mechanics. Na, komitang electrostatic part jong hi charge ho jong hi class 11 portion of mechanics ho tokon na tension ti ho vel tokon ahin combine te cho bang bang le. So here let's see two charged particles having charges hi charge q kipina. So are joined by insulating strings of length 1 meter. So here length of string. So are kept on a smooth horizontal table. So find the tension in the string. The question should be high. That charge nium so chipa q. Q chu zat ham 2 into 10 power minus 8 coulomb na. To chu lang khala jong charge khanuma jong chu 2 into 10 power minus 8 coulombs. To hi value chun chila hi chi string so chi. So this is a string. So length should be ham 1 meter na. Tang hi chila hi charge to hin charge evaluation ani positive chula na. So positive hong evaluation so there will be repulsion. Okay. So this charge will be pushed along this side with some force. This charge will be pushed along this side with some force. Hichi force part to hin hichi ga evaluation. So let's say let's concentrate on one of the mass na. Khadi A tiltin khadi B tilte. So B pa evaluation. So let's look at B. Chilanga hi tension chula na string ja so. Ale zilanga hopi mam Coulomb's law, Coulomb's force chila hilanga force na ale hin chila hi evaluation. So since they are tied with a string, so they will remain at rest. Okay, hita hi a string pa ga danding in a charge ten so rest samne na chang lo blit so. So if it is at rest means these two forces are equal. So y x axis as net force 0 tinai so. Okay. So the charge B is at rest, that means along the x-axis net force is 0. Kutile force minus T should be equals to 0, or you can say T is equals to F. Kibang tinecho. F should be K into Q1 Q2 by R square na. Value put legend K should be 9 into 10 power 9. Charge 10 should be 2 into 10 power minus 8 into 2 into 10 power minus 8. Divided by separation should be 1 meter na, 1 square. So here, how much is this? So 4 are 36 into 10 power. That 16 minus 7 na. So here, tension taso. So this is Newton. Or you can simply say tension equals to 3.6 into 10 power minus 6 Newton. Okay. Question tension do na. So this is your answer. Okay. Okay, next you have one more. GPM. Two identical charged balls, each of mass kipia, so are suspended from a common point by two insulating strings of 60 centimeter long. So length kipia. The situation GPH hitahi point khat na. So from one point they are suspended. Charge khatma. So silangahi charge khatom na si. So a weight GPM 400 gram each. 400 gram. So length of string to 50 centimeter. Okay, 50 centimeter. So when released, the balls are suspended at rest with separation of 60. Hutile amanika separation to 60 centimeter. Okay. Find the tension in the string and charge of its balls. So let's say Q is the charge. Kibang na identical. To hina let's say A to B la kirute na chala A B ti kirute. So A pa ko value chon A pa ko hita hem cho hilanga hi tension force na string ja cho. So here something like this. Mass of the 0.4 kg, so 4 Newton anulang ding. Kutile lang kala so charge of the force of repulsion hilang am dena velang ahi. Jitu chiten ka hi so eto bigi ka hi repulsion ng malachon e pa chu hilang ahi ke push dicho. So by electrostatic force. Hichipa hai na. Okay, so now value kipi ho chu ppm, so 50 kpa. So kutile nu ya pa 30 hi ngai na aki khacho. So total is 60. So which means this will be 40 and this angle will be how much? 53 degree. Okay. 3, 4, 5 triangle ho chala na angle 37, 53 ho chumel jita o chala hi. So here I can split this t into two components. So t cos 53 and t sin 53. Okay. So system here raise arm so raise ki suspend na. Kutila chun tension chuma suspend holote. Along the vertical net force 0 bole chun being pot de ha. So tension ho chung lang ko na t sin 53 ho t into sin 53 to 4 by 5. So this is equals to mg. So this is 4 na. So 4 gets cancelled out. Tension is 5 Newton. Okay, so we have found the tension in the string. And in the charge hole ngai na. Hotile charge hole na along the x-axis net force equals to 0. Atile pm t equals 45. T equals 53. Cos 53 to pm 3 by 5. Okay, minus f should be equals to 0. Atile t cos t to pita 5 Newton chalna. 5 into 3 by 5 should be equals to Coulomb's law chapiha 9 into 10 power 9 into charge to kibang chalna. So you'll have here q squared divided by separation between them chapiham 60 centimeters chalna. So 60 into 10 power minus 2 the whole square. So you solve for q here. So I will have here 3 into 60 squared, 3600 into 10 power minus 4 should be equals to divided by, so 9 into 10 power 9, so to q squared. Okay. Okay, then you have to solve this one. So 2, 7, so 9, 4 are 36. So 3 into 4 into 10 power is 7 minus 11 na. So this is q squared. So what I can do here is I can write 4 into 30 into 10 power minus 12 na. So this is q squared. Q is so q will be equals to, so 2 into 10 power minus 6 so root 30. Okay, root 30 is that approximation acho. Kavya root bolan ka helo chala. So root 30 to root 36 to root 25 ka amna. So 25 to 5 square is 36 to 6 square. Kutile 25 36. So here you have 5 gap, here you have 6 gap. Approximately you will have 5.5 lang podod root 30 na. Kutile value is podod so 2 into 5.5 micro Coulomb. 10 power minus 6 to micro na. So approximately you will have to 5.10 to 11 micro Coulomb. Okay, so these are the charges. Okay, here's a Coulomb's law na. Basic question hoiza mechanics to kirila jong solve hoza. Mita hina charge yung ke piding hichala jo tel khat modification ke bolle le na. Cha question ke dong le bacha. Next you have to learn one more concept here. The concept to biham dele the charge nium jona. Suppose you have two charges q1 and q2. Okay. His charge then biham dele they are brought together. Okay, they are brought together and then brought in contact. Hun ke sukha honda cha. Charge then hina. Ke sukha za chu so they are again separated again. Okay. Khutile his process so hi charge hi iti ke khial them. So value can put in so initially suppose you have here 10 micro Coulomb deute. Okay, micro 10 Coulomb deute la na. Khatpa hi let's say this is minus 20 Coulomb. Okay. Khatpa 30 40 laute 40 Coulomb khatchu minus 20. Khutile nan sukha wale na PTM de lechun he charge den yong ke sukha la chun ji conductor den yong ke sukha la chun, so there will be transfer of charges. So they will be like a one body. Okay. Okay, so this was 40 coulomb. So this was minus 20 coulomb. So when you brought into context, so there will be transfer of charges. Okay. Thadoukuki transfer then charge tensor Coulomb 2 total charge na aman ki Coulomb 2 so here this is possible if these two are identical. Okay, in most of the question you will have identical. Na so here the condition is Q1 and Q2 should be identical. Okay, remember identical charge na total charge equally they will be distributed. Okay, identical charge density ho involved na sigma ti ho rho ho involved phala chun chila cho chum involved ho na chila him. So now the total charge will be distributed. Total charge will be 40 minus 20 to 20 na. So 20 divided by 2 that ham 10. So each of the charge will have 10 coulomb after separation. Okay, right, here's the technique pa himel chi chun na total charge pa chu half in bol chun, so they will get each of them half. Okay. Okay, let's see this question. A small uncharged conducting sphere, uncharged kiti chupiham, so charge 0 na, no charge. So is placed in contact with identical kiti cho chala ta na syllabus identical kiti na spheres having this charge kharpa charge chu chi cho. Okay, let's say charge Q2, so Q1 to 0, and then remove to a distance such that the force of repulsion becomes this. Akinung separate zawachu force chu chipen hina. So then the distance between them is to chuvadai tai body nium cho body 1 to 2 tiuta. Atila 1 pa hi charge 0 na, so Q1. Khatpa chu charge piham, so 4 into 10 power minus 8 coulomb. Okay, so now they are brought in contact. So when they are brought in contact, okay, now the charge will be what? Total charge will be it's like 0 plus it's a value here. It's using total charge. So half of the total charge will go to one of them. So 1, 2. So each of them will get 2 into 10 power 8 coulomb. So the other one also will get 2 into 10 power 8 coulomb. Okay, half of the total charge part. So mani ki separate kida. Ita here 1 pa kinunglad okeda. A kinunglad also was a charge suicide tam 2 into 10 power 8 coulomb, 2 into 10 power minus 8 coulomb. Okay, so they are kept at some separation. Let's say this is x. Question x pa is at ham ta doja. Okay, so after they are separated again, new force is at the time. So new force to k into Q1 to be ham 2 into 10 power minus 8 into Q2 to be ham 2 into 10 power minus 8 divided by x squared na. So choose kpm 9 into 10 power minus 3 kp. So like it's a solve na 10 power solving in changsa. So 9 gets cancelled out. 10 power minus 3, so you'll have 10 power minus 5. Okay, so how much is this? X squared will be equals to 2 are 4 into 10 power is at so 13, 9, 10, 11, 12, 13 minus 4. Okay, square root la so x is equals to 2 into 10 power minus 2 meter. Okay, so this means this is 2 centimeter. Okay, separation between them. Okay, answer is B. Okay. Abana, two small identical conductors. Okay. It's a CBC question. So charges of 10, depending Q1 to 10, minus 20. So they were separated by distance R. Atila chu R is separated. So here let's say 1 and 2. Atila separation to R is a charge to be 10 microcoulomb to minus 20 microcoulomb. Okay. Experiences a force of F. It's like a force by F kp. So K into 10 microcoulomb. So 10 into 10 power microcoulomb. So 10 into minus 6 so 20 into 10 power minus 6. So divided by R squared. Like minus 20 by plus 20 because it's a magnitude of charge. So here how much will you have? So K into, so 10 into 20 is 200. Okay. Into 10 power minus 12 divided by R squared. It's a equation 1 tivte. Initial states as na. So so now if they are brought in contact, okay, and then separated to a distance of r by 2. Kutele, what will be the new force? To chuchala mass charge teni na 1 to 2 pa hi. So contact ahong ko ya bana chu, so they are brought in contact. 1 and 2. Kutele ahong ki contact alsun charge so data. So the sum of the total charge will be so the sum of the total charge divided by 2 na half so ke homun da cho. Chala total charge is ham, so 10 plus 20 minus 20 na, so that ham minus 10 half to minus 5. So each of them will have minus 5 microcoulomb and minus 5 microcoulomb. Okay, so Q1 plus Q2 by 2 possible na chala hi. So total charge will be distributed equally to both of them. Total charge is ham chala hi minus 10 na. Minus 10 to equal ake distribute alison minus 5 to minus 5 hongi diti na cho. So here now they are again separated to what r by 2 is separate kina jala hi. So r by 2. So now the charges in each of the sphere is 5 microcoulomb and minus 5 microcoulomb. Put the new force is at the time. So k into, so 5 into 10 power minus 6 into 5 into 10 power minus 6. So divided by r by 2 the whole square. Okay. Coulomb so ji palachun magnitude na hi ngai cha chu minus 5 jong chu plus 5 ta ke ji cho jela hi. So 5 by 25. So into, so anu ya r by 4 na, r square by 4 pa jong kal tau ding din. So k into 10 power minus 12 divided by r square. So is that the so 25 into 4 so 100 into k into 10 power minus 12 divided by r square. It's original part on compare. So original part here with to 200 so 200. So here you have only 100, which means the force has decreased by half. Okay, it's a part of hin. It's a part compare na. So here the new force will be equals to F divided by 2. Okay, so this is what they ask you. No, but then here team nova on chito hin. It's a divide bolachun. Just simply divide them and then solve them. You'll get this relation again. Okay. Next, two identical conductor conducting spheres P and S with charge Q on each of them. So P is there and Q is there. S zona. So charge PM Q so repel each other with the force force of repulsion. Let's say separation to R2 force PM, so K into Q into Q to Q square divided by R square. So that KPM 16 Newton KP. Question so a third identical uncharged, okay, is brought successively to one after the another in contact with the two spheres. So P part hin third part na, so third charge. Q equals to 0. Contact ahong so Q na, 0 charge. Okay. So first you'll bring this third uncharged conductor with the and put in contact with the first one. Abalachun, chizo palachun, it's the same conductor pa na. So Q part S part in contact ana hin koi kom kit dicho. S part so atila para plus Q anisa na. Atilachun in first when the third conducting sphere was brought in contact with the first with the P sphere, charge to that total charge of Q plus 0. So this is Q na. So half of Q is Q by 2. So one will get Q by 2. Q by 2 okay. So now when you bring the third with the S part of the to he third sphere pa hin charge anei ta so Q by 2 aji jo chima sanga so P to sun contact am hom chela na P aku na so Q by 2 kila so na chun to he third sphere pa hin charge Q by 2 anei ta so. So now when you bring this in contact with the S1 S sphere, total charge of Q by 2 plus Q to 3Q by 2 na. So half of 3Q by 2 so 3Q by 4. So the other one also will get 3Q by 4. Okay. na chidan jon he do chola na ma sa pena chu uncharged pa chu p to hong contact a home ding p a ku na chu q by 2 kila son ding to chu third pa chu s to chun contact a home ke de na so then after all of this process p to s chu charge is at ne hun tam so p chun q by 2 ane ya s chun 3q by 4 ane ta chu okay so with same separation r new force p tam so new force will be equals to k into q by 2 into so 3q by 4 so divided by r square is that so 3 by 8 into k into q square divided by r square its value is that kpm so 16 kp na chala hi 16 ko put le chun sarang podo de ham so 3 by 8 into 16 so 8 2 are 16 so 3 2 are 6 newton so answer is 6 newton okay okay let's do one more last one chi 2 command question na ki dong na dang ki bang vi ve chu chalai to hin hi chi pen hi ve le chun z means to 2024 question in jana je pen hi abana ve le chun NEET question 2025 okay so which means they took questions from z means directly okay then question to PM two uncharged conducting spheres A and B have their centers separately by a certain distance A to B to certain distance let's say that distance is R okay so charge on its sphere is Q so ni niyo na charge Q na so the force of repulsion between them is F so F to PM so K into Q square divided by R square so this is given next part to PM a third identical uncharged okay aso ata banga chona is brought in contact with the sphere A first and then with B and then finally removed from both aso I bolta bang ma cho atila cho A hi Q na chona so third part cho hong ki koya sinji pa he charge 0 khutela to he charge is other name ditam so Q by 2 and Q by 2 okay jizo phale chon he ji third sphere pa hi B to contact a home ke na so B to contact a home ma hi so B third pa chon Q by 2 charge anei ta cho so the other one has Q so now total charge is how many so Q by 2 plus Q2 3Q by 2 so half of this 3Q by 2 that means 3Q by 4 will go from the third will go to the third charge and again 3Q by 4 will go to B okay so new force of repulsion between the spheres A and B is that data so A to B to A chun za naitam Q by 2 anita na B chun za naitam 3Q by 4 anita so separation between them is unchanged okay so what is the new force of repulsion or attraction so K into Q by 2 into so 3Q by 4 now divided by that R square so 3 divided by 4 2 are 8 into so KQ square divided by R square KQ square by R square so PKBM capital F kipi na so therefore this is 3F divided by 8 answer to that so option B okay hechi concept pa he thim ding wa question kan solve jana question li leng solve ja okay so keep in mind na abana Coulomb's law vector form ana itik is ding ham so here to force to k q1 q2 by r square so na to example tang xy plane na ho let's say two charges q1 and q2 are there okay utile q1 pa hi x1 y1 am tib na any position this position pa chu vectorize evaluation let's say this is r1 okay r1 to position vector of q1 na ale r2 to pm so position vector of q2 khutele tila hi let's say we want to find out the force on 2 due to 1 na example 2 imagine yourself as 2 so how will you feel the force due to 1 tila hi q1 to q2 ha ani positive in ka assume le na positive hi la chun q2 pa hin force pa hi repulsive force experience di chona so it will be towards this side so force on 2 due to 1 okay ale man ki ka hi chi force pa hi ranga chi chona let's put the vector like this so this is r bar So R is the vector displacement vector between R1 and R2 na Q1 to Q2 ki ka distance pa chu vectorize evaluation R bar so na jala hi. So here if I want to write the force on 2 due to 1 so force on 2 due to 1 will be equals to K into so Q1 Q2 divided by mod of R distance na the whole cube into R whole square into R cube. Tang ihet ba wa K into Q1 Q2 by R square chola na formula cho R chu biham R mod R pa cho distance cho chen mani ki ka distance pa hai na. So distance square hong iding tin vector is easy wa cho direction hap ngai chola. Na direction cho welanga ji ham R cap ki ti cho R hi welanga ko so 1 to 2 chola na ji hi. So this is R cap. Okay, R cap. So direction is from direction of the force is from 1 to 2. Okay, so towards Q2. So the unit vector chupita R cap can be written as R vector divided by mod of R vector. So the value put leuchun F on 2 due to 1 chiti being pod ha. So K into Q1 Q2 divided by so mod of R the whole cube into R bar. Okay, vector form of Coulomb's law it's all here. So you can write like this. So force is equals to K into Q1 Q2 divided by mod of R cube. Mod R so biham distance between Q1 and Q2 na chepa value ba hi. So cube into R vector. Okay, so R vector so itikasita displacement vector. So if I'm going from Q1 to Q2, then it will be Q2 position vector minus Q1 position vector na. Vector displacement vector position vector also. So we're going to apply it here. Okay. So that is gravitation chapter gravitational force so the same thing we are using in electrostatic force also. Okay. The only difference is in place of capital G universal gravitational constant K ohm na. Abana in place of M1 into M2 here you have Q1 into Q2. Okay, chibo sa ki na. Amandan jong abon jong ke bang so ke na. He video pa chon he verwa he thiam wala chon chila jong ki bang cha cho chila he. See for example, one example. Let's take a triangle, equilateral triangle tiyo na. Equilateral triangle ahi mass charge thomum jos equal charge Q and Q. Question so biham tele what is the net force on any one of the charge to na chala he alhang pe vector form pa he ke man nahi system of particles ho na ong ki piphala chun system of charge ong ki piphala chun chala he ki haman so okay so you have an equilateral triangle side to a tiuten charge ki bang thumom na corner jo sia ale question so find the net force on any one of the charge. Okay, that is the question. Ale masa pena chu et bol jota so you draw xy axis. Okay, XYZ velang abana chu position hold ngai na ji so position vector is way ja chu khat pa chu 0,0 am ding khat chu a,0 am ding achunga pa khoi ta so a by 2, root 3 a by 2. Okay. So let's just name them. So charge 1, 2, 3 tiuta na. Net force chu 2 na hold out. So let's find the net force on 2, charge 2. So that means on 2, so between 1 and 2 I will have force of repulsion. Okay. Kutila 2 here. So force on 2 due to 1 chu plus x kai langa chi na repulsion. Abana between 3 and 2 force of repulsion chu F on 3 due to 2. Okay. Kutile charge dang talaw na. It's both in force ni both net force should be the sum of these two forces. Okay. So net force will be equals to net force on charge 2 should be so force 2 on 2 due to 1 plus force on 3 due to 2. Chite ni ko bole ke sizing na. Kutile chite ni force hold out chala him. So force on 2 due to 1 chu zading ham as a formula to apply legend. So K into Q into Q to Q square na charge ki bang divided by so distance between 1 and 2 chu piham chi na A. Okay. So A cube abana vector chu tin jidu ha displacement vector chu he force pa he chalang kaya chi chola na. So that means final value minus initial vector. Okay. Final position vector minus initial position vector. So biham A minus 0 x beta I cap pa he A minus 0 I cap plus 0 minus 0 z cap. So which means A I cap. So KQ square divided by A square I cap. Okay, force on 2 due to 1. Chito bang also force on 2 due to 3 zong hold on leuchen. is that the k into q square divided by a cube. So position vector 2, so a minus a by 2 I cap plus 0 minus root 3 a by 2 z cap. So a minus a by 2 to a by 2 I cap plus 0 minus 2 minus root 3 a by 2 z cap. Okay. So now you just have to add this too. Okay, net force to hold on. So I will put this whole thing here. Value po leusen sa po do di ham. So k q square by a cube to common na in both cases. Kung masang chun chilai dong a common do te. So a common la do leusen. Chilai dong a na khat to ki cancel la chun. So hilai a square da cho hilai. So therefore you have kq square divided by a square. So I will have here 1 by 2 a 2 zong common na 2 zong la do te. So I will have here I cap minus root 3 z cap. Okay. Okay, so that means kq square by a square is commanding in both terms. Okay. Chunga ko I cap bomding anu ya hepi ha. So plus 1 by 2 minus root 3 by 2 z cap. Okay. Confused na raw din chalai 2 ko idan ta chalai. So 2 chula do law. Okay, you solve this one is adang po do di ha chalai. So kq square divided by a square ma. So 1 plus 1 by 2 to 3 by 2 I cap minus root 3 by 2 z cap. Okay. Chi hi jing net force na ji. Nan me common ho ko na ka ala do theu na chala hi. So net force be ham. So net force 2. So root 3 jong command kq square divided by 2a square la do leu chun. So root 3 I cap minus z cap. Okay. In terms of vector and net force is ana to hi magnitude jong hol pe pe the jo jala hi hi net force pa magnitude hi zat ha. So hi chalai vector pa hi magnitude dik hol ha root over so root 3 whole square plus minus 1 whole square. Just use that ha. So 3 plus 1 to 4. Now root 4 hong ding chu 2 hong di cho. Okay. Vector magnitude hold on here chola na. So therefore what is the magnitude of net force? Is that ding ham chu. So here I will have root 3 into kq square divided by a square. Ji chu chalai hi 2 hong podo ding chalai 2 to cancel ding na 2 chu mang ta cho chalai hi. Okay, so like this gravitational ball tabang wacha na chala jong ke bang chala ki ball cha. So ki hi na charge bo se ki hi jana charge to constant pa ki hial jana ke pa hi. Okay, here you have what 3 equal charges having each having charge of depending kp charge value ju kp in chu. So this is q, let's say, are placed at 3 corners of a right angle triangle. So side to 3 4 5 kp. So find the net force force on the charge at the place at the right corner. Hit in balls te. So x y ten lao ten na right angle triangle chu ting ko te. So this is x silang pa hi y na atile he che pa hi 4 cm tiu tin. Chipai 3 cm Newton, chipai 5 cm. So 3, 4, 5 to ipiha Pythagorean triplet cho. Triangle kha side 3, 4, 5 ane ala chon chu right angle t nei cho. So right angle here. Charge q to charge q. Ki bang so ke na value jong 2 into 10 power minus 6 is okay cho bon ma cho. So here must happen chu khat pa 0,0 ama khat pa 4,0 am ding khat khu 0,3 am den na. So then we have to find out net force on the charge at the origin. Put the charge to 1 2 3 tiu te 2 na khu net force hold tiu na chala hi. So that means you will have force on 2 due to 1 and force on 2 due to 3. Aje chu 1 to 2 ke ka hi repulsion de na chu silang hi. Okay. So again, between 2 and 3 also you will have force of repulsion. Okay, like this. Hutile force to 0 chun happy yung di ham. So force on 2 due to 3 chu force on 2 due to 1 zi ma sao na. So k into q to q square as opala value you put divided by distance between them to be 3 cm na. So 3 cm to 3 into 10 power minus 2 the whole square. Abana chu displacement vector so it is force so jalang kaya tai chi chula na. So that means final minus initial. So 0 minus 0 I cap plus 0 minus 3 z cap. So that means you'll have 3 z cap. Okay, 3 3 chiong hi centimeter zo na. So 3 so into 10 power minus 2 z cap. Okay. Chila hi ga solve le chun 3 kha to 3 kha ki cancel ding in 10. So 9 into 10 power 9 into q cho pi ham 2 into 10 power minus 6 into 2 into 10 power minus 6. Okay. So divided by 3 into 10 power minus 2 into 3 into 10 power minus 2 square om ja na into minus 3 into 10 power minus 2 z cap. Chika solve le chun. So 3 into 10 power minus 2, 3 into 10 power minus 2 cancel na. Ban le pm na la ya. So 3 1 is 3, 3 3 are 9. So 10 power minus 2, 10 power minus 4. So 10 power minus 6 minus 10 so minus 1. So 3 4 are 12. So that means you'll have 1.2 minus z cap Newton. Okay, force on 2 due to 1. Chito bang force on 2 due to 3 ka bol na. K into charge to give q square divided by separation to 4 centimeter 4 into 10 power minus 2. Okay, formula is cube na. So this will be cube. Okay, so one thing here cube ding. So into 3 into 10 power minus 2 so that means so this 3 and this 3 also gets cancelled out. Okay. Minus 2 pa zong kaltaw din na pa zong kaltaw ding din. So that means I will have plus 1. So I will have here 40 Newton. So minus z cap. Okay, so I think this is the answer. First part na. As you minus 1 sa plus 2 kaltaw wala chun. So plus 2 minus 1 to plus 1 na. 10 tin so 2 into 2 to 4. So 40. Okay. Aba na pezong value chun k to 9 into 10 power 9. Yeah. Cube ding. So vector to tizidu ha. So force pa lang na. So this minus this. So that means I will have here minus 4 into 10 power minus 2 I cap. Okay. So plus 0 z cap na. 0 to 0 si solve le chun is ang podo di ham. So k to 9 into 10 power 9 is q to 2 into 10 power minus 6 into 2 into 10 power minus 6. Okay, so divided by so 4 into 10 power minus 2 into 4 into 10 power minus 2 into 4 into 10 power minus 2. Aban let's say so chung azong ko minus 4 into 10 power minus 2 khatom na line na. Chu I cap. Solve ke lechun. So 1 4 gets cancelled out. Is that here? So 2 are 4. So 10 power minus 2, 10 power minus 4. Okay. Then what else? So 10 power minus 2 kaltaw ding. So here I will have here minus 4. So that means I have minus 8. 10 to 4 so 10 mamahong kidin na. So that means I will have here 9 by 4. 9 by 4 so that for 2 or 8. For 2 or 8, 5 into 10 power 1. Na. So this is basically 22.5 Newton. That means minus I cap. Okay. So therefore, net force at the origin to so force on 2 due to 1 plus force on 2 due to 3. Na. I will have here so minus 22.5 I cap plus minus 40 Z cap. Okay. So I think this is the answer. Right, ball now here is the Coulomb's law vector form pa mandan pa na hi team so now na Japan here. Okay. So here you have one more. To hi square hungum na. So 4 corner of a square. Square hung kipin tin sila 4 corner hi charge ki bangso ke na. Charge ang ko below chun so ki bangkit na. So this is Q. So Q is here. So one Q, another Q, and another Q. Chita bangin gravitation asong ibol sa uta so same question na. Side to PKPM 5 cm KP. Let's say this is A. So each of the side has A. Iti bol di hama sa pena so XY ako ngay na sila hi. So this is Y, and then this is X. abale position chu pp ham khat chu 0,0 khat pa chu a,0 khat chu a,a abana chunga khu 0,a. Okay, then so let's name the charges now. 1 2 3 4. Question to find the Coulomb's force experienced by one of the charge due to the rest 3. Kutile charge 2 na net force hold out. So between 1 and 2 I will have force of repulsion along this side, force on 2 due to 1. So between 2 and 3 I will have force of repulsion, force on 2 due to 3. And between 2 and 4 I will have force on 2 due to 4. Okay, so along the diagonal. Along the diagonal I have diagonal root 2 into a na at length part or distance part. So here we have to find out the net force means the sum of these 3 forces. Okay, kutile masapena chu force on 2 due to 1 chu zadingham. So k into q to q square divided by a into a to a cube ongi dingai na abala chun vector chu ti jidu ha r bar pen chu. So 2 to 1 chu vita hetelanga chi chula na force chu, therefore this minus this, so a minus 0 a I cap. Okay, so here you will have k into q square divided by a square I cap. At any pen value put na. Similarly, force on 2 due to 3 chu zadiham k into q to q square divided by a cube. So force on 2 due to 3 parts. So this minus this, a minus a to 0, 0 minus a to minus a. So minus a z cap. So kq square divided by so a square z cap minus z cap. Okay. Abana force on 2 due to 4. Is that the hamsong k into q square divided by so root 2 into a the whole cube. Abana vector so piham hita force chicho. So that means this minus this. So a minus 0 to a I cap. Okay. So 0 minus a to minus a z cap. A who cancel kill leujun kq square divided by a square. 2 root 2 cube to piha 2 root 2 chulana. So 2 root 2 into a square. So I minus z. Okay, so now you add all of this. So net force should be so the sum of all those. So I cap is you so in all of the term you will have kq square by a square common. Remaining could be so I cap minus z cap. So plus 1 by I by 2 root 2 minus z by 2 root 2. Okay. Common so kq square by a square. Common so 1 plus 1 by root 2 common heading. Okay. Abale I minus z. So I think this is what you will get. That's a value put leujun k value put velang q value put velang a value put leujun cha answer ng posing da so jala him. Magnitude no holum vazong le magnitude chu ting pot odi ha. So this whole thing square root of leujun. So root over 1 square plus 1 square chu root 2 na. So root 2 to chun it shows is in the multiply kid do magnitude whole na so na. So that will give you the magnitude. Okay, so mod of f net will be equals to root 2 to multiply boleuchen. So you'll have root 2 plus 1 by 2 into kq square divided by a square. Okay. Chichu answer is na value tatan hen valachun chichi q hel hen chi value hi put velang a hel hen chi value hi put velang na solve leuchen. Okay. So you do that. Next part, last part. Last part here equilibrium problems on kitin na. Net force wila 0 di ham da question jang dong visi to. Example jabata. Sila charge kharom cho q1. Sila charge dang kharom q2 na. So let's say separation between them is r, okay. Question jo biham tele. So where should I put the third charge? Okay. Charge dang khachuna. Wila ka koya lechun hiche charge chung asun net force 0 ding ham. Suppose I explain that na khachu biham tele charge khachuna wila ka koya lechun hiche charge pa hi rest ding ham. So it will not move. That means the net force on this charge is 0. The whole system is in equilibrium. Okay. So where should I put the third charge such that the system is in equilibrium? Where should I put the third charge such that the net force on the third charge is 0? Asay dan teni chuna chum chum hicho jalahi. Jalahi derivation nima jang bolda tin result kan pidi wachi result ani hi apply le chuna. Question na bolna jau si wachu ki apply thei cho je. so not chu pi ham tele masa pena chu so q1 to q2 chu na so if q1 and q2 are of same nature chu pi tina ha ani ni huna plus charge heading ai lo le ani ni huna negative charge heading na so in that case so third charge so like koi ding ham third charge so should be placed in between them. Point number 1 chu na asi chu betang tu in third charge sin plus tiu ta ni plus cho ku de le tu chun third charge chu lang koi leng so between due to q2 so there will be force of repulsion okay and due to q1 also there will be force of repulsion ku de le f1 to f2 chu ani na zilang kol chun charge chu chilang chi ta chu la na res aum thei te ro chu la so similarly weilang a jong he na charge third charge koi leng so due to this one you will have force of repulsion so due to second charge also you will have force of repulsion so there will be no net force not possible ai wang alai ta hong ma le chun so due to q1 force chu chilang am na f1 due to q2 force chu chilang ayum kit cho so f2 so there is a chance of net force becoming zero f1 to f2 chong ki ba so net force 0 ta chula okay alai la bo sia chu net force 0 a hin ding a chance ti nei cho so the third charge should be placed in between them okay q1 to q2 ki ka achu third charge nan ko yungai na chela hin a second na point cho biham q1 to q2 pa he na so if q1 and q2 are of opposite nature ti chu khat plus a hiya khat minus a hi le chun na chi ke sa chu piding ham te le so third charge so yang ko diu ham so third charge so should be placed on side of smaller charge chi ten chi pen hi mel chi lo chuna chi mun do sana man theu chu a chi question hi board exam a jong ke dong so chi pen hi chi da bang he na entrance exam a jong ke dong kin lai na so in both in any type of question so like this you can apply okay he chi technique pa hi mel chi lo chun side of smaller charge neo pa om na lang ning langa chuna na koi te te ngai example chalai betang so in this case if q1 is less than q2 okay and they are of opposite nature kha chu minus is a kha chu plus a hile chun a neo zo pa chu hilang ha so q1 chu neo zo chula na so chilang side ai third charge na podu na koi dio so if this is x then the distance of this from the other charge will be r plus x ita he om ngai na okay tu hin hi pen point ni mel chi lo chu no question example ni ham khat bol te na chi phala chun clear ti da chu charge tin chu nature ki ba la chun ani na plus plus ham ai lo la ni na chu minus minus ham ai la chun third charge pa chu alaya koi ngai na ai wanga charge nature chu ki ba lo kha chu minus a hi kha chu plus a hi la chun aneu zo pa lang kaya chu na plus pa chu neu zo ham ai lo minus pa chu neu zo ham aneu zo pa outside a chu koi ngai third charge chu hi electric field jong ki dong thai force jong ki dong thai potential jong ki dong thai chu so hi ho thom topic a hi na example where so find the point on the line joining where the electric field is zero where the potential is zero ta jong question ki dong thai chu hi chi question ho jong ho che technique hi na chi point ni na apply ki ngai okay then let's solve I think this is the last question is solve masang bin example khan ga solve ate na so let's say isa de la de ha so 2 Coulomb tiu te na 2 Coulomb to silong hi 4 Coulomb tiu te example so separation between them to 10 centimeter laute question 2 where should a third charge na third charge pa chu value chu anom no me thai chu kholo the value of the third charge is not important okay where you place is important na so question 2 where should a third charge be placed such that the net force on the third charge is zero ta jong ki dong thai chu khutele isai ma bang chu alai ta koi ngai na he che nature ten equation chong hi plus chi jong hi plus cho khutele the third charge should be placed in between them let's say at a distance of x from 2 then the other distance will be 10 minus x okay so due to 2 Coulomb force is let's say f2 and due to 4 Coulomb force is let's say f4 tiu ta na chila hi third charge pa hi positive lao to chipen positive hi alachun. So between these two you will have repulsion F2. So between these two you will have force of repulsion along this side. Okay. So net force 0 na, net force 0 here, net force of F2 plus F4. So this should become 0. F2 should be between 1 and 2. Third charge pass to Q now. Let's say third charge is Q. So some Q plus Q. So between 2 and Q, so K into 2 into Q divided by X squared. It's a force between 2 and Q is a. So this is lang ko na. Kapen to minus K into 4 into Q divided by 10 minus X the whole square. This is 0 hingay. So is that diha sila hi. Kapen ko lang transfer leochon. So K into 2 into Q divided by X squared should be equals to K into 4 into Q. So divided by 10 minus X the whole square. Cancel today, cancel leochon na. K. So Q. Sila hi beta. Third charge pa ki cancel to dosing licho chizi acho magnitude po mo po kati cho sila hi. So 2 1 is 2, 2 2 are 4. Is that dingham? So here I will have 2 into X squared should be equals to 10 minus X the whole square. Cross multiplication bol leochon na. So now you take square root on both sides. So root 2 into X should be equals to 10 minus X the whole square should be equals to, so plus minus root 2 into X. Square mang talay. Okay, take square root on both sides. So here you solve. So 10 minus X equals to plus root 2X. So value khat na. Ay lawle 10 minus X equals to minus root 2X. So which depends on answer D ding ha. So 10 equals to X plus, so 1 plus root 2 into X. Okay, so X will be, so 10 divided by 1 plus root 2. Value khat na. Khat ko biham. So 1 minus root 2 into X. So X equals to 10 by 1 minus root 2. Second value pa value root 2 hilin so na 1 sanga cho. The whole thing here negative hong kiso. So distance cannot be negative, so this is not possible. Answer cho piham chipen hi answer na. Okay. Ikat ama sa pena cho third charge pa cho hui lai place ding ham chipen zon her masadong ai na. Okay. Let's solve one more question and not that much. So two particles A and B having charges 8 and minus 2 are fixed. So 8 into 10 power minus 6 to 2 into 10 power minus 6 minus 2 na jala hi. Hita ki koi cho separation to 20 centimeter ki pia. Question 2, where should the third charge be placed such that it does not experience a net electric force? Kasi bang so to hi charge tani evaluation chi plus 8 is a chi minus 2 na ni charge ki bang talo pichala. Opposite hong hi alachon you have to put the third charge on the side of the smaller charge. So third charge, let's say Q tu na. You can take any value, okay? So let's say at a distance of X from minus 2. Kutele third charge pa jo 8 apala ho chana gamla am 20 plus X a gamla na jala hi. So at a Q, so force due to 8 would be repulsion na. Third charge pa jo positive laute. So force due to 8. And force due to minus 2 should be towards attraction na. Third charge pa so plus a hilachon 2 pa ho minus 2 is a attraction ding. So that is force on 2, let's say. Okay. Kutele net force 0 hingay na lahi. So net force should be F2 plus F8. So this should be 0. F2 pa ho velang ko so minus F2. Okay, so therefore you can say F2 is equals to F8. F2 should be force between 2 to third charge pa na. So K into, so 2 into 10 power minus 6 into third charge to Q. So divided by X squared. So this should be equals to force into 8 into 10 power minus 6 into third charge to Q divided by 20 plus X the whole square. Okay. Chiga solve leochon na X value pot beta. So K gets cancelled out, Q gets cancelled out. 10 power minus 6, 10 power minus 6, 2 1 is 2, 2 4 are 8. So I will have here 20 plus X the whole square should be equals to 4 into X squared. So take square root both sides, 20 plus X equals to plus minus 2X. Value possible value niyom na masa penachu. So 20 plus X is equals to 2X is a kat penchu 20 plus X equals to minus 2X. masa pa ko solve la chun x is equals to 20 centimeter hong pode na ani na pa ko solve la chun minus x minus 3x is equals to 20, so x is equals to minus 20 by 3. Distance to negative thelo cho, so therefore this value is invalid. So your answer should be 20 centimeter. So third charge pa chu 20 centimeter from minus 2 an ko yung na 20 centimeter abana chelai pa ko na hi total chu ham 40 centimeter agam hata cho. Okay. Question na so how far from this charge how far from this charge ta jong kitong thai cho chi chu x ne het pha le chun is anagam tham na so charge khat pa ko na chu is anagam tham khat pa ko na chu is anagam tham hi cho jong in he thi ngai na ji theu ngai. Okay, so that much electric field ball pha jong leo che ta bang question hi ball ki tiu cho to apai mo chu biham te le chelai point te ni email chi leo chun na charge te ni chu same nature hi le chun third charge pa chu between them hi ngai na charge te chu opposite nature hi le chun third charge pa chu on the side of smaller charge ano ko yung ngai cho chelai hi. Okay, Coulomb's law force is anju hin. It's an hing out na abana hu electric field or potential or involved ki so. So I hope you understand whatever we have done. So we'll stop here and I'll see you in the next video. Okay, so thank you for watching.